In this video, we're looking at learning target 4C. It says I can simplify equations to determine if it is linear or nonlinear. And so this time we're working on the equations and we're trying to decide on key features of equations, what makes an equation linear versus nonlinear. I'm right now in what's called standard form in this equation. The x and the y are on the same side. And so I want to see it in slope-intercept form and see if I can then determine if it has a constant rate of change in there. Okay, so I'm going to draw a line down the equal sign, and I know in order to get it in slope-intercept form, it has to be a y equals form. That's what we're trying to get to. So we're going to get rid of this 3x by subtracting out the 3x on both sides. When I do that, I'm left with just 2y. So 2y equals, and I cannot combine those because those are not like terms, so it's 10 minus 3x. Okay? I'm still not in y equals because I have a 2y. It's 2 times y, so I want to undo the 2 by dividing by 2. When I do that, I just get y on this side, but I have to divide everything by 2 on this side. And 10 divided by 2 equals 5, and negative 3 divided by 2 equals 3 over 2x. It could also equal 1.5x, right? And so now when I see it in this format, it looks like the same format that we're used to seeing linear equations. The x is being multiplied to a number called a coefficient, and that's going to be our rate of change right there. So we're going up 1.5, or I'm sorry, we're going down, because it's a negative, down 1.5 for every time we go over 1. And so this is linear, because it has a constant rate of change of negative 1.5. Looking at B, so right now I need to simplify this in order for me to decide whether it's linear or nonlinear, and then I'm going to look for key features of that equation and decide whether it's linear or nonlinear. I'm going to take this x and I'm going to multiply it in. It's distributive property. So what this was looking like is possibly an area model using this as a tool right here. You're saying I'm going to multiply x to everything inside. So x is going to go here, and then you got 4 plus x here. And so then to find the area, it's called the area model. So you're finding the area inside here would be 4 times x, which would be 4x. And x times x is known as x squared. And so when I bring this back to my equation, so this is equivalent to what that is up there, then I end up with 4x plus x squared equals y. And so I see this 4x, and I would assume originally that this is linear because the 4 would be the constant rate of change, but then I see another x over here, and I have a problem because that x is squared. And so if I were to start to make table values of this x is going to modify that, and I'm no longer going to have a linear equation here. And so I'm going to call this nonlinear. And the reason why it's nonlinear is because the x is squared. There is an x with a square on it, and so that would not give us a straight line. Okay? Moving over to the second one, I'm looking at what I have here, and I'm thinking it's already in y equals, and everything is simplified. There's nothing else I can do, and it's looking a little funny right here, as in what's my rate of change. So I want to just work on this piece right here. So I'm just going to write here x over 4, and we're really going to make sense of what x over 4 means. The number x is just a placeholder for us to put a number into it. So if we're talking about how many x's do we have, well, we really have 1x over 4, right? So I can put an invisible 1 there. And then if I say, what do I really have? What number do I have? I really have the number 1/4 x, right? 1/4 times x. And so then I would say, well, I have a constant rate of change because now I can rewrite this thing as 1/4 x plus 7 equals y. And so then I can say this is linear because I have a constant rate of change of 1/4. It'd be going up 1 for going over 4. I can see that when the x is in the numerator, it is linear, okay? Because in the numerator, it's in the top piece, would still keep it linear, okay? Because you can multiply things by x and still be linear. That's what we have here. You can't divide things by x and still be linear. But in this case, you'd be multiplying a value, and that value is 1 there. All right, moving on to the last one. This looks pretty similar to this. The only thing that's different is it's the reciprocal, meaning that the fraction has been flipped. Okay? So we're thinking about this, what this stands for, and the x is in the denominator position. And so if it's in the denominator, it's no longer linear because just referring back to a table to make explanation here, that if you have the number 0, you should be able to have an answer for 0, right? That would be your y-intercept. But think about this. If I were to substitute my 0 in for the x there, then it's 4 over 0 to give us our y value. And if you were to try that in your calculator right now, you would see that 4 over 0 is an invalid operation. You can't divide anything by 0. And so therefore it's called undefined. And so if it's not even a point, then you wouldn't even be able to have a y-intercept, and it wouldn't have a rate of change, because then when you go to 1, you wouldn't have any value here to be adding or subtracting by, because undefined is not the same thing as 0. Making sense? I hope so. So we're going to call this one nonlinear, and it's nonlinear because the x is in denominator. All right? So doing on your owns, getting them completed, turning it in, I will sign you up for retest.